this lesson we're going to focus on surface area of prisms specifically. We'll get to surface area of some other things, but for now we're just going to talk about surface area of prisms. Now surface area is exactly what it sounds like. It's the area of just the surface of something. So if you were to look around your room or your kitchen or your living room, wherever you're watching this video, or even the classroom, what you're figuring out is what's the area of all the walls, the floor, and the ceiling. Well, before we can get to that, we're going to kind of take a look at what are all the pieces that combine those things to make up the surface area. Well, the first thing we want to look at is a net. I know we talked about this a little bit in the lesson that we did last time, but I want to review and just make sure that we're all on the same page with what is a net, because that's really what you're finding the area of. So a net is a pattern that you can fold to make a three-dimensional figure. So what that means is that if I have this rectangular prism, looks kind of like a flat box, if I had this box and I unfolded it, so if I cut it apart at the seams and I unfolded all of it, it would look like this. So what that's looking like is I have the bottom piece, I have the front and the back, so my bottom's down here, I have the front side and the back side, then I have the top. So if I unfolded all of that, that would all be connected by the creases, and then I just unfold the sides from the bottom. So anyway, this is what we are finding the area of. You're finding the area of each of these squares or rectangles or whatever they are. So once we take a look at this, now we're ready to find the actual surface area. So the surface area is the area, the sum of the areas of all surfaces. Another way to think about that is all the sides or the faces of a 3D figure. So if I wanted to find the surface area of a triangular prism, okay, so we have So the important thing to recognize is how many faces you're looking at and what all the sides are. So if you look of a triangular prism, we would be looking at two triangle areas, because we have the front and the back, and then three rectangle areas, because you have this side, the other side, and the bottom. And so that's why nets are going to be important, because they're going to help us kind of isolate and look at what are all the different sides that we have, top, bottom, and all the sides, and what do we need to find the area of. So this is the formal definition of surface area, is just the sum of all the surfaces or all of the areas of those surfaces of a three-dimensional figure. So let's take a look at a particular example, because it seems kind of daunting, but it's not really that hard. It just takes some thoughts and some breakdown of what we're looking at. So they gave us, now I'm not going to draw an actual juice box. The example says find the surface area of the juice box. We're just going to look at the area of this box. So if you know what a juice box looks like, it's tall, it's a rectangular prism, right? And then if we were really to draw the juice box, we'd have some kind of a straw coming out the top. You don't have to draw the straw is just there for fun. However, the height of this is 10 centimeters. The length of this is 6 centimeters. And the width of our juice box is 3 centimeters. So it's important to look at which pieces are which dimensions and how we're going to figure out what all the areas are. So that's why we're going to go ahead and draw the net of this juice box and figure out all of the different areas. So if I start with the back is that tall rectangular piece. Then off to the side we have the the narrower and tall one. And then connected to that would be the front of it, which matches the back. Then we have the other side. And then off the back you could draw the top and you could draw the bottom. Okay? So remember that this is the back of the juice box. This is, if you're looking at it, this is going to be our right side. This is the left side. This is the bottom. This is the top. And this is the front. So remember that these two are, this short piece here is going to be 3 centimeters, which means it's that way for both of those. It's 6 across the front, so there, 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 and there. And then the height going the whole way across here is 10. So it's our job to look at this and figure out, okay, how does all this match and what are we looking at for the area? We want the area of all 6 rectangles. So this left side over here, we'll just start here and move our way over. The short sides are 3, the height is 10. So what's the area of one of my sides of this, of the left side? Well, it's going to be 30 square centimeters. So this one is 30 square centimeters. Well, if the left is 30 square centimeters, the right also matches at 30 square centimeters. Because those two are exactly the same. The front and the back are going to be exactly the same. The top and the bottom are going to be exactly the same. So once I figure out the back, which 6 this way, 10 this way, so this is 60 square centimeters. That means the front is also 60 square centimeters. Well, this is a 3 by 6. So this is 18 square centimeters, which means that this is 18 square centimeters. And then to find the total surface area, which I'm just going to call SA, we would just add up 30 plus 60 plus 30 plus 60 plus 18 plus 18, and all of that is going to give us 90, and 90 is 180, and 18 is going to be 98, and another 18 is going to be 116 square centimeters. So take a minute if you need to, pause the video if you need to make sure you have all of those dimensions, that you're comprehending what we found the area of, that you're understanding where all of that came from. And then we are going to do one more. Alright, let's go ahead and move on. Alright, let's do a triangular prism this time. So let's take a look at, if I had something like so that's our triangular prism. Notice the front and the back are both triangles, and then all the sides are going to be rectangles. Now with this one, the only ones that we know are the same are the front and the back. The sides are not all going to be the same. So it's a little different than a rectangular prism because that's a box where you're looking at two of these, and two of these, right? Well, this one, all three of these are different, but the triangle in the front and the back are going to be the same. So let's say we have here a height of 12 centimeters, a length of 5 centimeters. This side is 13 centimeters. Now notice that we need more dimensions than just 3. On the other one we use the same 3 dimensions everywhere, a length, a width, and a height. Well, on a triangle, we need to know this and this because it's the height, the base and the height of the triangle. But then we need to know this piece because that's going to give us the area of that rectangle, right? So then we also need to know that this is going to be 2 centimeters in width, right? So if I were to draw the net of this, this would be the back, and then we have the bottom, then we'd have the other side, and then we have the side coming off this way. Then we also have to have the front, and when we unfold it, it would go this direction. So remember, the height of this is 12, so if that's 12, this was 13, and this was 5, and our width was 2. Remember, that means this width is 2, this is 13, this is going to be 12, right, and this is 5. So take a minute to draw that net. Make sure that, again, you're comprehending where all of those pieces are coming from, how it was unfolded, and what dimensions are which. I want you to take a minute, see if you can figure out the surface area of that triangle. And when I come back, I'm going to go ahead and show you the answer so that you can check your work. So remember, the area of a triangle is 1/2 the base times the height. So to find the area of our triangles, it's 1/2, my base is 5, and the height is 12. So what is 5 times 12? That's 60, cut in half is 30, I made it centimeters again, so 30 square centimeters. Well, that means this is 30 square centimeters, and this is 30 square centimeters. Well, this bottom piece here is going to be 10 square centimeters. This is 2 by 13, so that's 26 square centimeters. And this is a 5 by 12, or excuse me, 2 by 12, so it's 24 square centimeters. So when we add all of those up to get the total surface area, we end up with 30 plus 30 plus 26 plus 10 plus 24. So when I add all those up, we end up with 30 and 30 is 60. 26 is going to give us 86, 96, 120 square centimeters. And again, we're in square centimeters. even though it's a three-dimensional figure, it is still area. So you're still measuring it in square centimeters. And so that concludes our lesson on surface area of prisms. Next time we're going to dive into what is the volume of a prism, and how do we find that. So we're still going to be in with three-dimensional figures, and eventually we'll move into cylinders.